All right, hello. I just wanted to go over a couple of the little trickier problems that we've done in these sections for the test Thursday and Friday for my pre-calc kids. This came off your worksheets. The first one, question 4 is, it is known that f of x is a linear function. They tell you this. Okay, so you don't have to figure out if it's linear or exponential. And that passes through the two given points. Write an equation for this function. Well, it's a linear function, so you can use the point-slope form of the equation. Y equals mx minus x1 plus y1. All right? So we got two things we have to figure out. One thing. We have to figure out the slope, and then we can use either point to write the equation of the line. But the thing is, we have to find the slope. For linear, it's real easy because you've been doing it since whenever you took Algebra 1. That's going to be m equals the change in y over the change in x, which is literally, you can go, change in y would be 1 minus 7 over 8 minus 3. Which gives us a negative 6 over 5. That looks horrible. Over 5. So we got our slope. Now we can just use either of the 2 points. Y equals negative 6/5 x minus 3 plus 7. Or, and you don't have to do both on the test. Y equals negative 6 over 5 x minus 8 plus 1. Either of these two equations satisfies answering the question. Again, that one was not too hard. Probably the hardest one would be this. They tell you it's an exponential function. Okay? And they give you 2 points. So they want you to write an equation for this function. Well, we know that exponentials are y equals a b to the x. Okay? So we have to figure out what the base is. Well, we're given 2 points. We actually have 2 unknowns. The easiest way to do this would be to put each point in. I'll put in the 412 first, so that I get 12 equals a times b to the 4th. And then I'll put the other one in and write 5 equals a times b squared. If I just divide, and again, this was done in your notes, this is a little bit different than what he did to figure out the base. On the video that you have linked to this, you end up with 12/5 equals b to the 4th over b squared. This, when you have division of powers, you subtract the exponents. So you get b to the 4 minus 2, which is b squared. So now that we got b squared equals 12/5, we take the square root, and we get b is equal to the square root of 12 over 5. We don't put plus or minus because b is the base of an exponential, and the base of an exponential, by definition, is always going to be positive. All right, so that's why there's no plus or minus. So there's my base. Now just use the point, it's kind of like the point slope form of the linear equation that we used up here, but it's for exponentials. That is y equal, actually f of x, I suppose. Probably f of x for the linear too. Yeah, I probably should have said f of x instead of y. Okay. Just to be more clear. Okay. Now, for this, we found the base, but we're going to use the point slope form, not the point slope, the point, exponential form of the exponential function. That is the fact that y1 equals, what do you call it? Not y1, y That's what I'm looking for. Y equals y1 times b to the x minus x1 power. All right? We don't know what b is. That's what we're looking for. But we found it right here. This is b. So we know that we can write y equals y1 square root of 12/5. I'm not trying to simplify the square root. You don't need to. You can. But I'm here to tell you, if you make a mistake on your simplification of it, I'll have to dock you points. And we can choose either point that was given. That is, we could use 2/5 or 2/5 or 4/12. So just to write both, you only have to do one though. 2/5 would look like this. Y is 5, 2 comma 5, not 2/5. The base is the square root of 12/5 to the squared, or x minus 2 power. Excuse me. Okay, that's 1. And maybe that should have been f of x, not y. You won't get docked points if you write y. Or you can write f of x equals the other point, which is 12. 12. Same thing, square root, 12/5 for the base, x minus, what is that, 4? Yep, x minus 4. Either one of these. And that is the equation of the exponential that passes through the two given points. Notice they told you it was exponential because they only gave you 2 points. All right? If they gave you like 3 points, then you could show that's exponential, and then you could do the same thing, that you would choose 2 side-by-side points and come up and solve for the base. Now, another example is deciding if a given table of values, like this, is either exponential or linear. Well, how do you do that? To first of all, check the x's. 1, 2, 3. They go up by 1 each time, and you go up by the same amount each time. It doesn't matter that it's by 1. It's the fact that they go up the same amount each time. Now, let's check what's going on with the with down here. Here, if we have to add negative, oh no, not negative, but add 8 to go from 8 to 16. And to go from 16 to 32, we would have to add 16. So no, it's not arithmetic. So let's try exponential. To do that, we have to see what we have to multiply by. And the easiest way to do that is to take the number to the right divided by the number to the left. So 16 over 8, or 32 over 16. It looks to be that they are equal. It's 2. So we know it's proportional. So this is yes. So f of x is exponential. And then we just have to use the techniques we saw in the previous problem. We know that r, or b, the base, is 2. So we can write y equals y1 times 2 x minus x1. Just choose either of these points, any of these points. 1, 8, 2, 16, or 3, 32. I'll use the last one just because most kids won't. So I would say y equals 32 times 2 x minus 3. And that this is the equation, and that's a valid equation that matches the data points. You could check it when x is 1. You have 1 take away 3 is negative 2, and 2 to the negative 2 is 1/4. 32 divided by 4 is 8. So it works. You could try when x is 2. 2 take away 3 is negative 1. 2 to the negative 1 is 1/2. Half of 32 is 16. All right? And when x is 3, 3 minus 3 is, 3 minus 3 is 0. 2 to the 0 is 1 times 32 is 32, and it matches that point. So that's the equation. There you go. I hope that will help you understand how to do some of these problems. And I'll see you either tomorrow morning or Friday morning. Have a good one. Bye-bye.